Hey everybody, today we're going to be talking about concatenation with happy numbers. So first off, what is a happy number? Well, let me just explain it through an example. I think that's the best way to explain it. So let's start with the number, 82, right? And what we're going to do is we're going to take its two digits and square each of them. So I'm going to say this is going to be 8 squared plus 2 squared, okay? So 8 squared is 64 plus 2 squared is 4, so we get 68. And then we're going to do this process again. We're going to do 6 squared plus 8 squared. And 6 squared is 36, 8 squared is 64, you add them together, and you get 100. Let's do it again. We get 1 squared plus 0 squared plus 0 squared. And that is 1, right? Because it's just 1. And if you keep trying this process over and over, you're just going to get 1 squared, which is equal to 1, and then it's going to keep going in a loop, right? You're just going to stay at 1. So because we end up at 1, we call this a happy number. So this process of taking a number and then splitting it up into digits and squaring each of those digits and keep doing that over and over, if you end up at 1 at some point, the number is happy. But if you don't end up at 1, then your number is sad. Yeah, they're real things. So how could you tell if a number will not end up at 1? Because it's easy to tell if it does end up at 1. You just do it a bunch of times and eventually it'll get to 1. Maybe it takes 100,000 iterations, but eventually it'll probably reach 1. Okay, but when can you say, no, it's not going to reach 1? At what point do you get? Well, you're gonna, if you don't end up at 1, you're gonna be stuck in a cycle, right? So maybe you go between one number here and another here and another here, and you just keep going in this loop. So this number, you do this process and it gives you this number and then this number, and then you just go basically in a big circle. It could be a smaller cycle, it could be a large cycle, but you'll end up in a cycle. And eventually you'll kind of come back to one of the numbers where you were before, and then you'll realize, oh, you're just going to repeat that process. So I recommend looking at the Wikipedia article for happy numbers for more explanation on that, but this is pretty much what we need to know. So there's some sort of limit going on here. As we iterate this over and over, if we get to 1 at some point, then the number is happy. So if we take the limit as, and I'm going to say k for our iteration, goes to infinity, right? Because, it could be a large number. We don't know how many iterations. It could be a few like this, or it could be 20 million iterations until we end up at 1. So let's just say we're going to go all the way to infinity, right? Because if we keep doing this, if we iterate this process an infinite number of times after this point, we're just still going to stay at 1. So if the limit as k approaches infinity of some process, and we're going to describe that process, if this equals 1, then our number is happy. But if it's not equal to 1, then the number is sad. So what is this process? Well, we're going to have to start with some recursive definition. And like I mentioned earlier, we're going to be using concatenation to help us. Now, the way to think about it is, okay, well, we're going to kind of break up our number. We're going to unconcatenate it, right? So let's first label these. So I'm going to call this capital H sub 1. All right, this is just what I wanted to call it. So then this is going to be H sub 2, H sub 3, H sub 4, H sub 5, and so on, right? Okay, so we're going to take H sub 1, right, so our first number, and I want to split it up. So first, I want to mention that it's not always going to be a 2-digit number. We could choose a 5-digit number or a million-digit number. It doesn't matter how many digits. But yeah, and of course it can vary, because here we jump from a 2-digit to a 3-digit to a 1-digit, right? So the number of digits will vary. So our first number, well, we can write it as the concatenation of a few numbers. So I really you need to watch my second video on concatenation to understand what's going on. I'm going to assume that you already watched it. So yeah, let's just move forward with that. And I'm going to, again, use the kind of general notation that I invented. And I'm going to say this starts at, I equals 1 to n of some numbers a, right, a sub I. Okay, so what did I just write down here? Basically what I'm saying is 82 is going to be 8 concatenated with 2. Right? Because this is definitely equal to each other. And if we had a larger number, let's say our number was like 167, I don't know, 284, right? Then I would say this is equal to 1 concatenated with 6, concatenated with 7, concatenated with 2, concatenated with 8, concatenated with 4, right? I'm basically kind of unconcatenating our number. I'm basically saying our number, the first number that we choose, can be written as a concatenation. And that's what this represents. However, there is a slight issue with our number, because as I said, the number of digits in each number in the iteration will vary. This n cannot be the same, because this n describes the number of digits, but in that particular number. 82 only has 2 digits. 100 does not have 2 digits. 1 does not have 2 digits. So we have to index, we have to introduce another index. So on top of the index that describes the term, we have to introduce another index. Actually, before I get into that, I don't think I explained a too well. A just kind of represents the particular digit we're talking about. So, and sub I is the index, like this is the first digit, and then the second digit, and so on, right? So we're gonna, as I said, reindex it. So I'm gonna say this is n sub 1, because this is for our first number, the maximum number of digits, or I guess the number of digits in our first number is represented by n sub 1. And I have to reindex this as well, so for a sub 1 sub I, right? Let me make that clear. So what I'm saying here is a sub 1, I'm talking about our first number, or the digits in our first number, right? If I was talking about h sub 2, right, so this guy, I'm going to represent this as the concatenation I equals 1 to n sub 2 now, right, because we had n sub 1 here, so this is our second number, so n sub 2, there we go, of a sub 2 sub I, right? So a sub 2, a sub 2 basically represents a particular digit in h sub 2, and the index represents which actual digit we're talking about. So then you can start generalizing it. You can say h sub 3 is equal to I equals 1 to n sub 3 of a sub 3 sub I, right? And by the way, the notation I'm using with the parentheses and another subscript, you can probably represent that in a few ways, but I think this is a clear way to do it. So now for any h sub k, we're going to represent this as the concatenation from I equals 1. Actually, let me move this down a little bit so this is not too confusing. So h sub k is equal to the concatenation from I equals 1 to n sub k of a sub k sub I. So this doesn't actually get us anywhere, because like what I'm doing, like this is just a way to represent our kth number in our process. We need to actually do the process now, right? This is a representation of each number in our process. Now we have to have a way of going from this to this to this and so on, right? So what we're going to do is, let's actually, now that we've broken it up by term, because we have this term here, now we can say, okay, well, 8 is one of these terms, and we're going to square it. This guy, we're going to square it as well. So what we're going to do is we're going to sum up, because that's what we're doing, we're summing up all of these, right? We're going to sum up from I equals 1 to n sub 1, right? That's the number of digits we have, of a sub 1 sub I squared. So the particular term squared. So 8 is our first term squared, 2 is our second term squared. All right. So what this is this will give me not h sub 1, but h sub 2, right? Because when I do this, so let's actually use an example. So remember I said this is 8 concatenated with 2. Here, what I'm saying is, okay, well this is going to be 8 squared plus 2 squared, right? 8 squared is our first, and n sub 1 is just equal to 2 because we have 2 digits here. So there are just two things that we're adding, 8 and 2, 8 squared plus 2 squared. And this is equal to 68, as you see over here, which is h sub 2. So we know that this is going to be equal to h sub 2. So now we have a way of taking this information and transferring it to the next one. So we can continue this. Let me do one more example here. So we have to get to h sub 3, we're going to take I equals 1 to n sub 2 of a sub 2 sub I squared, and that gives us h sub 3, our third number in the iteration. So in general, we're going to have that the sum from n equals 1 to n sub k minus 1 is of a sub k minus 1 sub I squared gives us h sub k. So this is what we want, right? We want this. So we know that this is equal to that. Okay? And it depends on the previous one. So now we have a way to represent this, right? Okay, so what do we do, right? Well, like I said, we're going to have to define this recursively.